Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. I've shared my screen, children. Is it visible?
Yes, ma'am.
Yeah, let's continue. Yeah. So let's continue from where we stopped. We finished till here in the last class. Yeah, so this is the next one. Find the coordinates of the point equidistant from three given points A, B, and C. Don't work. Please listen. Find the coordinates of the point equidistant from three given points. Okay. Three given points A, B, and C. All right. So let P be the point. Let P x comma y be the point equidistant from the three given points A, B, and C, which means PA, the distance PA is equal to the distance PB is equal to the distance PC. Okay, so PA is equal to PB is equal to PC because the point P is equidistant from A, B, and C. So PA is equal to PB is equal to PC, which also means PA square is equal to PB square is equal to PC square. If A is equal to B is equal to C, then A square is equal to B square is equal to C square. Okay, so take up the first case. Take up this one. PA square is equal to PB square. PA square is equal to PB square. So you know how to find PA. Distance formula PA using the coordinates of P and A. You don't have to show the square root symbol because it is PA squared. All right. So you don't have to use a square root symbol on both the sides. So how do you write? The difference between the x coordinates, the whole square, plus the difference between the y coordinates, the whole square. So x minus 5, the whole square, plus y minus 1, the whole square, is equal to PB square. So use the coordinates of P and B. Use the coordinates of P and B. Difference between the x coordinates, the whole square. Difference between the y coordinates, the whole square. So work PA square is equal to PB square. Work PB square is equal to PC square. Okay, that's case 2. Case 1, PA square is equal to PB square. Case 2, PB square is equal to PC square. You can also, it's enough if you work any two of the three cases. The third case is PA square is equal to PC square. That's not needed. You can work three, case 1, case 2, case 3, but work any two of the three. You don't have to do all the three. So here I have done PA square equal to PB square and PB square is equal to PC square. Okay, so from these two, you get two equations. You get two linear equations in x and y. Linear equations in x and y. Write the equations one below the other. Use the elimination method and solve the equations to find the values of x and y. Yeah, now start working. All of you understand the procedure? Yeah, please work. Okay, I'll present it. I don't want anyone to waste time. I'll present the answer, but please don't copy blindly. Understand what you're working. And if you have any doubts, please ask me. So x square on either side gets cancelled. Y square gets cancelled. Done working? Shall I take you to the next slide? Completed, children?
Yes, ma'am.
Okay.
No, ma'am.
Ma'am.
No. Okay. Okay. I think if you have not completed, children, take a screenshot and complete it. Taking you to the next slide. Yeah. So please see here. I've just worked it in a different way here. Now PB square. PB square is that's the usual thing, PB finding writing PB square and PC square. This step, Now after this, you can expand like you did earlier. You can expand this one, expand this, expand this, expand this. But what I have done is just to introduce you to a different way of simplifying this. We have x plus 3 the whole square here. I've transposed this. And we have y plus 1 the whole square. I've transposed this. So I'm having the expressions with x on one side and y on the other side. It's not compulsory to transpose, children. You can simplify them. You can expand using the formula a plus b the whole square, a minus b the whole square directly. This is just an alternate way of working. Okay, so I'm having these two expressions which have x here on one side and these two expressions which have y on the other side. So now how do they look like? They look like a squared minus b squared. A squared minus b squared. What's a squared minus b squared? A plus b into a minus b. This one also looks like a squared minus b squared, which is a plus b into a minus b. Now simplify. So you can see x minus x gets cancelled. So 3 plus 7 is 10. Right? And here x plus x is 2x and 3 minus 7 is minus 4. So like that, just simplify. And this is a second equation. Solve the two equations to find the values of x and y. Yeah. Please work. Getting the x expressions on one side and the y expressions on the other side. So now it looks like a squared minus b squared, which is a plus b into a minus b. Sure, I made a mistake. Minus into minus is plus 7. So you'll get 8 here. This wrong. Just check my working, children. I think I made some typing mistake. You just work this with you. Oh, I was right. Now you will have to solve the two equations to find the values of x and y. First equation, x plus y is equal to -2. So we'll multiply this one by 5 or 3. Equation 1 multiplied by 3 gives, what is equation 1 into 3? 3x, 3y is equal to -6. And here 5x, this is the second equation. 5x plus 3y is equal to -2. Change the signs. Change the signs. So 3y minus 3y gets cancelled. Minus 2x is equal to -4. X is equal to -2. Substitute the value of x in one of the two equations. So if we put x is -2 here, y is 0. Oh my God. You should tell me my working children, because there is a difference in the answer I have here and here. Yeah. Quickly tell me. Am I right so far? X is equal to 2. So when you substitute, you'll get y is equal to -4. So the point is 2 comma -4. Therefore, the required point is 2 comma -4. Okay, next one. Completed, all of you?
No.
Okay. So the point P 2 comma -4 is equidistant from these 3 points A, B, and C. Yeah, please work this one. There's nothing much to explain in all this, children. So I'm just presenting the answer. You can help yourself. Because everywhere it's just using the distance formula. Yeah, please work this one. I'll just come back. Completed, all of you?
Yes, ma'am.
Okay, very good. Yeah. Okay, so what is given here? O is the center of the circle, and the coordinates of O are given to be 2, minus 3y. So here we do not know the value of y. Okay, and then we have 2 points A and B lying on the circle. On the circle meaning on the circumference of the circle. O is the center of the circle. A and B are 2 points lying on the circumference of the circle, on the circle. So clearly OA is equal to OB because radius of the same circle. So OA is equal to OB is the equation, which means OA square is equal to OB square. So we know how to find OA square. So you should not use a square root symbol because it's OA square. So here also don't use a square root symbol. In the distance formula, we have the square root symbol. We don't use it because it's OA square and OB square. So write this and this using the distance formula. Simplify using the identity or, whatever here. Yeah, so here there are like terms. 1 minute. So 2 plus 1 is 3, 3 squared. This is minus 4y the whole square. This is minus 3 the whole square. So here, children, remember that minus a minus b the whole square can be written as a plus b the whole square. You can just remember like this. I'll tell you why. I'll tell you why. Minus a minus b the whole square can be written as a plus b the whole square. See, this is minus 3y minus 7 whole square. You can simply write it as 3y plus 7 the whole square. See, that's what I've written in the next step. Why? Because minus 3y minus 7 whole square. Now see it, whole square, okay? Now inside I'm taking out minus common, minus 3y, minus into plus is minus 7. So now what is minus squared? Plus. So it's nothing but 3y plus 7 the whole square. I'll show you again. See, we have minus 3y minus 7 the whole square. Okay, so see this whole square is out here. Now, in this expression, I'm just taking out minus, open a simple bracket. So minus 3y, minus into plus is minus 7. Just taking out minus. Now, minus squared, minus into minus is plus. And 3y plus 7 the whole square. So there's nothing but 3y plus 7 the whole square. So please remember, you can make a note of this. Minus a minus b the whole square is equal to a plus b the whole square. So you can see 3y plus 7 the whole square, expand that, and then, simplify, bring all the terms to one side. You get a quadratic equation. And so here I've divided by 7 throughout. So you get a simpler equation. Y square minus 6y minus 7 is equal to 0. Split the middle term and find the two values for y. So y is 7 or minus 1. Okay. So here are the coordinates of O. So it will be 2, when it is 7, minus 3 into 7, minus 21. Or 2, minus 3 into, when y is minus 1, minus 3 into minus 1. So plus 3. See, y is 7 or minus 1. See, here is y, no? Use 7 or minus 1. So O, the coordinates of O are given by 2, minus 21 or 2, 3. So now we found the values of y. Next is to find the radius of the circle. So to find the radius of the circle, find OA or OB. Anything. Okay, find OA or OB, whatever. But we'll have to work two cases because we have two different centers, right? We have two different centers. So you'll have to find the radius when the center is at 2, 3. And you should also find the radius when the center is at 2, minus 21. I have used, I think, I found OB. That's what I see here. You can even find OA, radius, right? So you can find OA or OB, anything. I found OB, the radius. But you'll have to work two cases. One when the center is at 2, 3, and other when the center is at 2, minus 21. So what I've done here is O 2, 3 and B 5, 7. So difference between x coordinates 5 minus 2 the whole square plus difference between y coordinates 7 minus 3 the whole square. So here I've used O 2, minus 21 and B 5, 7. Okay, center at 2, minus 21 and B 5, 7. So difference between the x coordinates 5 minus 2 the whole square plus the difference between the y coordinates 7 minus 21 the whole square. Yeah, please ask me if you have any questions. Any questions, children? No response. Okay. Yeah, this is the next one. Find the center of a circle passing through the points 6, minus 6, 3, minus 7, and 3, 3. You must find the coordinates of the center of a circle. The circle passes through these 3 points. The circle passes through these 3 points. Okay. The circle passes through these 3 points. That means these 3 points lie on the circumference of the circle. With this, you'll have to find the center of the circle. So we know that PA is equal to PB is equal to PC. You can even take this O, children, O. Okay, so you know OA is equal to OB is equal to OC. So OA square is equal to OB square is equal to OC square. Work any two cases and find the coordinates of the center. Yeah, please work. Since the answer is there, I have nothing much to say. Go through the answer and work it out. Done, children? Have we completed, children? Please respond.
Yes.
Okay. All right. So we'll see the question again. We need to find the coordinates of the center of a circle. The circle which passes through these 3 points, 6, -6, 3, -7, and 3, 3. So these 3 points lie on the circumference of the circle. We need to find the center. We need to find the coordinates of the center of the circle. So we know OA is a radius, OB is a radius, OC is a radius, or PA, PB, and PC, whatever you've taken. So case 1, PA square is equal to PB square. Case 2, PB square is equal to PC square. So when you work case 2, you're able to find the value of y. So when you substitute that in the first one, you find x. X, y are the coordinates of the center. So 3, -2. Yeah, try this. Okay, see, we've been, like working with the distance formula. I hope all of you know that clearly. So distance formula is given by square root of difference between the x coordinates. Difference between the x coordinates. So you can write x1 minus x2, or you can write x2 minus x1, the whole squared, plus the difference between the y coordinates, y1 minus y2, or y2 minus y1. Anything you can write, whole squared. Square root of difference between the x coordinates, the whole squared, plus difference between the y coordinates, the whole square. That's a distance formula. Please work. Okay, so here are the vertices of uh, a right angle triangle, right angled at B. So you can see the figure here. Right triangle ABC, right angled at B. You can see we have the coordinates of A and C, but in the coordinates of B, the x coordinate is not known. In the coordinates of B, the x coordinate is not known. So we have to work to find the x coordinate of B. So you need to find some relation between these three vertices. So since they are the vertices of a right angle triangle, you can use the Pythagoras theorem. So which means AB squared plus BC squared is equal to AC squared. Pythagoras theorem. AB squared. AB squared is AB is the distance between the points A and B, or the length of the line segment AB. AB squared. AB is the length of the line segment AB. So use the distance formula, and we don't put the square root symbol because it is AB squared. So this is eliminated. So like that, use the distance formula and write out for AB squared, BC squared, and AC squared. That's it. Quadratic equation. We get two values for P. When P is 7, what happens when P is 7? B is 7, 3. But C is also 7, 3. That means the points B and C coincide. So then B cannot be 7, 3. So B has to be 4, 3, the other value for P. We find two values for P, but when P is 7, the coordinates of B are 7, 3. But we already have C 7, 3. So that means these 2 points will coincide. But it's a triangle. So P cannot take the value 7. So P has to be 4. So the coordinates of B, 4, 3. Okay. Next one. This one, children, last class we had taken up this. What did we do with this one? Did we work, or we have to still work this one? Please tell me.
We discussed it, but we didn't work it.
Okay, okay. Thank you, Niveda. Thank you so much. Yes. Yeah, please work. So we've been using this identity a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. In the simplification, we've used this identity. A minus b the whole square plus a plus b the whole square is equal to 2 of a square plus b square. And what you should be careful is root 3. 3 is under the square root. A is not under the square root. A is not under the square root. Only 3 is under the square root. So when you square it, root 3 into root 3 is 3. A into A is A squared. Yeah, you should ask me if you have any doubts. So to show that the points are the vertices of an equilateral triangle, find the lengths of the three sides and show that they are equal. So if the three sides have the same length, it's an equilateral triangle. And formula to find area is root 3 by 4 into side square. Completed, all of you?
Yes, ma'am.
Okay. Yeah. Yeah, about this. Isosceles means two sides should be equal. Right angled, so you should check Pythagoras theorem. Isosceles, two sides equal. Right angled triangle, you must check Pythagoras theorem. If both are satisfied, then it's a right isosceles triangle. Yeah, please work. Completed, children?
Yes, ma'am.
Okay, thank you, Mitsa. So here, show that the points, 4 points are given to you, taken in order are the vertices of a rectangle. Also find the area of the rectangle. Okay. Now, if we show that opposite sides are equal, then it's a parallelogram. When we just show that opposite sides are equal, it's a parallelogram. To show that it's a rectangle, you need to also show that the diagonals are equal. So in a quadrilateral, when opposite sides are equal and diagonals are also equal, it's a rectangle. If only opposite sides are equal, it's a parallelogram. Just make a note of this and write it out for you. Yeah. Opposite sides equal, parallelogram. Opposite sides equal and diagonals equal, rectangle. All sides equal, rhombus. All sides equal and diagonals equal, square. See, if in all these, cases, 4 points will be given to you. 4 points of four corners of a quadrilateral will be given to you. And you may be asked to prove that it's a parallelogram or a rectangle or a rhombus or a square. Supposing you have to prove that the 4 vertices, the 4 points are the vertices of a parallelogram. Just show that opposite sides are equal. If opposite sides are equal, it's a parallelogram. If all sides are equal, it's a rhombus. If you have to show that it's a rhombus, you must show that all the sides are equal. Then it's a rhombus. So if opposite sides are equal, it's a parallelogram. If all the sides are equal, it's a rhombus. So supposing you have to show it's a rectangle. It's not enough if you show opposite sides are equal. If you have to show that it's a rectangle, it's not enough. It's not sufficient if you show opposite sides are equal. You must also show that the diagonals are equal. So when opposite sides are equal and the diagonals are equal, it's a rectangle. Similarly, to show that it's a square, if you just say all sides are equal, if all sides are equal, it can be a rhombus. It need not be a square. So if all sides are equal and the diagonals are equal, then it's a square. Yeah, please make a note of this. Just give me a minute, I'll come back. Make a note of this. Okay. So here we'll have to show that the points are the vertices of a rectangle. And we also have to find the area of the rectangle. Okay, so see here, we found the sides AB, BC, CD, and AD. They're all equal. All, sorry, not all are equal, sorry. We found AB, BC, CD, and AD. We need to show it's a rectangle, and you can see that the opposite sides are equal. AB is equal to CD, 2 root 5 units. Okay, and opposite sides BC and AD, they are equal, 4 root 5 units. So opposite sides are equal. But when simply opposite sides are equal, it's a parallelogram. You need to show that it's a rectangle. So you also have to find the diagonals. Okay, diagonal AC and diagonal BD. Find AC and BD. You can see the diagonals are also equal. So it's a rectangle. And then find the area of the rectangle. L into B. Please work. Just turning off my camera. I'm right here. Completed, children? Okay. All right. Next one. So you'll have to show that the points are the vertices of a square. So when you show that all the sides are equal, it's a rhombus. All sides are equal, it's a rhombus. To show that it's a square, you also have to show that the diagonals are equal. See, okay, I'll just mention one more thing here. If opposite sides are equal and the diagonals are unequal, diagonals are unequal, it is a parallelogram and not a rectangle. And not a rectangle. If all sides are equal, all sides are equal and diagonals are unequal, it is a rhombus and not a square. So sometimes the question will be, show that the points are the vertices of a parallelogram and not a rectangle. See, the difference is if you're asked to show that it is a parallelogram, it is enough if you show that opposite sides are equal. But if you have to show that it's a parallelogram and not a rectangle, then you should also work the diagonals. And in that case, the diagonals will be unequal. So, since opposite sides are equal, it's a parallelogram and diagonals are unequal. So, it's not a rectangle. It's only a parallelogram, but not a rectangle. In a parallelogram, opposite sides are equal. Opposite sides are equal. Diagonals unequal. Diagonals unequal in a parallelogram. In a rhombus, all the sides are equal, but diagonals are unequal. In a rectangle, opposite sides are equal and the diagonals are equal. Diagonals are equal. In a square, all sides are equal and diagonals are equal. See, listen carefully. If we have to prove that it's a parallelogram, it's enough if we show that opposite sides are equal. If opposite sides are equal, it's a parallelogram. But if the question is prove that it's a parallelogram but not a rectangle, then you must also find the diagonals and show that the diagonals are unequal. They're not equal. Diagonals are not equal. So it's a parallelogram but not a rectangle. Similarly, to show that it's a rhombus, it is enough if we show that all the sides are equal. All sides are equal, so it's a rhombus. But if you have to show that it's a rhombus and not a square, then you should also find the diagonals. And you should show that the diagonals are not equal. So since all the sides are equal, but the diagonals are not equal, it's a rhombus and not a square. If the diagonals are equal, then it's a square. In this case, in a parallelogram, when the diagonals are equal, it's a rectangle. In the case of a parallelogram, when the diagonals are equal, it's a rectangle. In the case of a rhombus, when the diagonals are equal, it's a square. Yeah, please make a note. Taken down, children?
Yes, ma'am.
Okay, thank you, Mritza. So look at this one. You'll have to show that the points are the vertices of a square. So show that all the sides are equal and the diagonals are equal. So it's a square. Please work. Completed, children?
Yes, ma'am. Yes, ma'am.
Okay. Very good. Okay. Yeah, look at this one. We have 4 points in a plane. Show that ABCD is a rhombus but not a square. Find the area of the rhombus. You must show that it's a rhombus and not a square. So when you show that all the 4 sides are equal, it's a rhombus. But that's not enough. You must show that it's a rhombus but not a square. So you must also find the diagonals. Diagonals will be unequal. So since all the sides are equal and diagonals are unequal, it's a rhombus and not a square. If it's a square, the diagonals also will be equal. If all sides are equal and diagonals are unequal, it's a rhombus and not a square. If all sides are equal and diagonals are also equal, then it is a square. Yeah, please work. And the formula to find the area for rhombus is half product of diagonals. Formula to find the area for rhombus is half product of diagonals. Half diagonal 1 into diagonal 2, half D1 into D2. Yeah, please work this. Done, children?
Yes, ma'am.
Okay. So the formula to find the area for rhombus is half into D1 into D2, or in words, half product of diagonals. Okay. Prove that the points ABC are collinear. So when we have 3 points in a plane, there are only 2 possibilities. Either the points are collinear or they form a triangle. If they are not collinear, they'll form a triangle. But we know that we need 3 points, right, to form a triangle. We need 3 points to form a triangle. So when is a triangle formed? When the 3 points are not collinear, then a triangle is formed. Look at this. Now here we have 3 points. But the 3 points can be connected by the same straight line. So which means the 3 points are collinear. So what happens here? If you call this ABC, AB plus BC is equal to AC in the case of collinear points. AB plus BC is equal to AC. So this is a check for collinearity. This is a check for collinearity. Now, if the points are not collinear, see these 3 points are not collinear, then they'll form a triangle. So when we have 3 points, there are only 2 possibilities. Either the 3 points are collinear, that means no triangle is formed. No triangle is formed when the 3 points are collinear. Or if the points are not collinear, that means a triangle is formed. Yeah, please work. As I just told you, the check for collinearity is if the points are like this P, Q, and R, PQ plus QR will be equal to PR. Yeah. Please work. Okay. So when we find A, B, B, C, and AC, see, we don't know the arrangement. We don't know if it is A, B, C like this, A, B, C like this, or if it is like A here, B here, and C here. So we don't know the arrangement. So we're just finding out A, B, B, C, and AC. Now look at the lengths you get 3 root 5, 5 root 5, 2 root 5. So from the answers we have got, we understand that the sum of these two is equal to this one. So what is AB plus AC? It is 3. See, how do we know that we have to add these two? By looking at these values. By looking at these values. So we know that 3 root 5 plus 2 root 5 is 5 root 5. So what is AB plus AC? AB plus AC is 5 root 5. And what is the third one? BC? That's also 5 root 5. Okay. So the sum of these two line segments AB and AC is equal to the length of the third line segment BC. So that means the 3 points are collinear. Okay, and the arrangement is BC is the longest. BC is the longest. So it's BC 5 root 5 like this. BC and A lies somewhere between B and C. So BA is 3 root 5, AC is 2 root 5, and BC is 5 root 5. This is the longest. So 3 root 5 plus 2 root 5, that is AB plus AC is equal to 5 root 5. And BC is also equal to 5 root 5. So AB plus AC is equal to BC. AB and AC, right? So the arrangement is like this. The 3 points lie like this. Or it can be like this also. A, A is basically between B and C, children. So it can be C here and B here also. C can be here and B can be here. A basically lies between B and C. So it can be BAC or it can be CAB, any order. So remember, this is a check for collinearity. You must find AB, BC, and AC. Look at the answers. The largest one is 5 root 5. So add the remaining two, AB and AC. We get 5 root 5. So that's equal to BC, which is also 5 root 5. So since AB plus AC is equal to BC, the points are collinear. This is not a formula. This one is not a formula. This one depends on the arrangement of the points. Here I told you, this is AB and AC, right? 3 root 5 and 5 root 5. Actually, it's very easy to make out. See that you have A, B and AC. A is common, right? So A lies between B and C. AB, AC. A is common. So A lies between B and C. So it can be B, C, A like this, or it can be C, B, and A like this. Just a second. Yeah, we'll do the first one and wind up the session for today. Just the first one. A and B given to you. Find the distance AB. Please work and tell me the answer. Oh, sorry. So what's the value of sine 60? What's the value of sine 16?
Root 3 by 2.
Root 3 by 2. Root 3 by 2. Sine 30?
1 by 2.
1 by 2. So you can substitute the 1 by 2. Yeah. So A, 5 sine 30, 5 sine 60, comma, 0. B, 0, comma, 5 sine 30. So this is A 5 into sine 60 is root 3 by 2, comma 0, which means A is 5 root 3 by 2, comma 0. B 0, comma 5 into 1 by 2, which is B 0, comma 5 by 2. Now we need to find the distance AB. Now please take the question and get the answer. So 5 squared is 25, root 3 squared is 3. So 25 into 3, 75 by 2 squared is 4. 5 squared 25, 2 squared is 4. Okay. We'll do the fifth one and wind up the session, children. Please try the fifth one. P, Q, R, S are the vertices of a parallelogram. Find the values of A and B. Okay. So we know that in a parallelogram, the diagonals bisect each other. In a parallelogram, diagonals bisect each other. That means O is the midpoint of PR. O is also the midpoint of QS. Okay. In a parallelogram, diagonals bisect each other. Okay. This means O is the midpoint. O is the midpoint of PR, diagonal PR and diagonal QS. Okay. Now what's the x coordinate of O? Now O is the midpoint, right, of QS. Now we can find the x coordinate of O in two different ways. X coordinate of O using diagonal PR. See here. How do you find the x coordinate of O using the diagonal PR? O is the midpoint, right, of PR. So by the midpoint formula, x1 plus x2 by 2, x1 plus x2 by 2. So that means a plus 2 by 2. What is the x coordinate of O using diagonal QS? O is the midpoint of QS. So how do you find the x coordinate of O? x1 plus x2 by 2. 5 plus 1 by 2, which is 6 by 2, which is 3. So a plus 2 by 2 is equal to 3. Cross multiply. A plus 2 is equal to 6. A plus 2 is equal to 6. So A is equal to 4. So the value of A is equal to 4. Take down. Similarly, we'll have to find B. Okay, now let's find the y coordinate of O. The y coordinate of O using the diagonal, anything you can find first using the diagonal QS or PR first, whatever. How do you find the y coordinate of O using the diagonal PR? Y1 plus Y2 by 2, because that's a midpoint formula, right? To get the x coordinate of the midpoint, it is x1 plus x2 by 2. To get the y coordinate of the midpoint, it is y1 plus y2 by 2. So 15 minus 11 by 2. 4 by 2, which is 2. But we can also find the y coordinate of O using diagonal QS, which is b plus 1 by 2. B plus 1 or 1 plus b by 2. You can see the y coordinates, 1 and b. Okay. So both are the same, right? The y coordinate of O. So clearly, b plus 1 by 2 is equal to 2. So b plus 1 is equal to 4. B is equal to 3. So these are the values of A and B. We can do it in one step itself. I'll show you that in the next class. Okay. Finish writing, children?
Yes, ma'am.
Okay. So see, what's the question? It's given that PQRS is a parallelogram, and we have to find the missing coordinates A and B. So here we use the midpoint formula. We know that O is the midpoint of both the diagonals. O is the midpoint of both the diagonals. So we'll find the x coordinate. You can find the x coordinate and y coordinate separately. X coordinate of the midpoint is x1 plus x2 by 2. The y coordinate of the midpoint is y1 plus y2 by 2. So find the x coordinate of O using both the diagonals, using the diagonal PR and QS. Equate both. That will give you the value of A. Similarly, find the y coordinate of the midpoint using both the diagonals, y1 plus y2 by 2. Both are the same. It's a y coordinate of O. So b plus 1 by 2 is equal to 2. Cross multiply, b is equal to 3. Class, use the emoji, raise your hand. Bhavishya, Prenu, Jayavashni, Swati, Hari Pranav, Nritsa, Blessy, Tanishka, Anugraha, Ragamai, Pratish, Niveda, Sabarna, and Sadhna. Shakti, are you there? Okay. All right, children. So that's it for today's session. Thank you so much. Good night. You may leave the call.
Thank you, ma'am.
Thank you, children.